Hello. Hello and welcome to this video. In this video, we are going to discuss closures in JavaScript, and they are a very important concept because you can do a lot of things with them. So what are closures? Before you can understand closures, you have to understand lexical scoping. The other word for lexical scoping would be, if I choose a close enough word, it would be static scoping. Static is a word with which you can replace lexical. Now, what does it mean? What it means is, in JavaScript, when a function is executed, it how to put it, it executes with the environment in which they are defined, not the environment in which they are invoked. Okay. So the simpler way to put it is that a closure captures its environment. Now that may not be very obvious what it means, but with some examples, it will be clear. Technically, all JavaScript functions are closures because the lexical scoping is applied throughout the program. And that is why all functions are closures. But to capture something, there has to be something to be captured. And that is well exemplified by nested functions. So let's see here. Okay. So one of the simplest examples is we have an outer function. We have a message called hello, and we have another function. It logs the message. We return this function object and we print. So it will print hello. Let's see this in action. So we run this and it prints hello. Not very clever, right? Okay. Let's take another example. So, okay, we take this example. Now, if you look at this example, we have x is equal to 10 here. First logs the x, then we have second. In the second, we declare another function, 20, and then we call this first, and then second is there. Now, what should it print? Should it print 10 or 20? Now, what happens here is that this closure, because first is also closure and second is also closure. When first was invoked, it will look at this x and it is available to it, but it is not, this x is not available. This x becomes available when second runs. Therefore, it will print 10 because they care about the environment in which they are created, not the invocation environment. So once we have understood this, we can do several useful things with this. For example, we saw the unique counter, I believe in this one. Yeah, this one. So unique counter, you see, we have a counter variable outside this. So what we can do is we can bring that counter inside a function. Now this function is no longer available globally. This value is not available globally. This count variable can be only modified through the increment interface. So you create a closure, it remembers when it was created, so count was initially 0. An increment is called, it increases, it becomes 1, and 1 will be printed at this call. Then in the second call, since it remembers its environment, this count will become 2, and 2 will be printed in the second console log. So that is what we mean when we say that closures remember its environment or captures its environment. So it remembers that the value of count has been increased. Okay. Now we look at another function. Okay. Now it is similar to previous function, but now we create two different counters, C1 and C2. Now what happens here is these two different closures will capture different variables. So those variables are independent of each other. They are not the same variable. So count, when C1 is created, it prints 1 and 2. But when C2 is called, its count was still 0. And it will also print 1 and 2 here. So it's not that the captured environment is shared. The captured environment is not shared by closures. Okay. Now we'll look at another example. So in the last example, we saw that different closures have different environments. In this one, they share the environment. Multiple methods are here: increment, decrement, value. Okay, and it's an object. And they share the count variable. All of them now share it. Okay. Now we create the counter and we call increment once, twice, and thrice. So count at this moment will be 3, right? And when you print the value, it should print 3. And then you decrease it, it should print 2. There we go. So with this kind of combination, we can have situation where the environment is shared as well as not shared. Now, this classical property of JavaScript was used to create classes when class was not a keyword. For example, in this is a bank account function which takes a balance, and deposit takes an amount, adds it to balance. Withdraw takes an amount, subtracts from balance, and get balance returns balance. So there is no way to change this balance. Once the class is created, there is no way you can change the balance other than calling through the interface. You can't modify this balance directly. For example, this account is created with the balance 200. So once you have created, the only way you can modify the balance is through deposit and withdraw interface. You can get its value, but you can't change it. The only interfaces are deposit and withdraw. So for example, we deposit 200 and we get the balance, it should become 700. So this is the classical way in which class-like objects were created before the class keyword became available in JavaScript specification. So that was a very interesting use of closures. Then we have function factories here. Okay. So here what we do is we pass a variable n to multiply by, and we have a function which takes an argument x and multiplies that with n. So we create a multiply by object with 2. So n is 2 here, so that will be captured. It's a closure now. It will double everything you pass to it. And then we create something to triple. So we pass 3, and now n is 3. Anything we pass to function, it will be triple. So if you supply double a value of 10, it will become 20. And if you supply 10 to triple, it will become 30. So it's a kind of function factory. Okay, account is not defined. So we run this again, and we have 20 and 30. So we saw how clever closure usage can be. Then we can have kind of what we call. So here we take a greeting language, and then we have another function inside it which takes name. And depending on the logic, the the logic changes. Okay. So you can say that without modifying this code, we can change the behavior by passing language. So it is kind of strategy pattern. Okay. And even if you change the implementation of the inner algorithm of this switch, okay, the interface is not changing. You can add more languages at any point of time, and this will start working. Okay, so your change of logic does not modify the interface. So it is kind of strategy pattern. Now we'll see some uses in scripts in front end which comes. So in browser, when JavaScript runs, you may want to delay something. So you call set timeout function, put your logic in the set timeout and give a timeout, and then it will be a delayed greeting. So it will run after 2 seconds. So this greeting will come after 2 seconds, as we will see. So see, we have to wait, and then hello John comes. So this is more useful in the browser environment. And then we have the classic problem which we see in case of what you call var. So suppose we have var 1, 2 less than equal to 5. So after 5, it will become 6. Okay. And this closure will capture it. So the value 6 is now captured. It will print 6 5 times. So one of the solution of this is to make it non-capturing variable. Okay. So you do use let. In that case, it will print 1, 2, 3, 4, 5. That is one of the solutions. The second solution is to convert it into another nested function and make it a closure and supply I to it. Okay. And you see, this will also work. So these are various uses of closures, and you can be quite creative. But I think the example has covered most of the cases where you can use closures depending on the requirement. So these are one of the most interesting aspects of closure in JavaScript, which I have shown to you. And make sure that you understand this entire example, all the examples of given in this video, so that when you, for example, study legacy code, and in legacy code you encounter something like this, or you encounter something like which one? Yeah, this one. Then you should not be surprised that how it works. Because legacy code will have this kind of code at all the places, and mostly you will encounter it in front end, because Node.js code base, if you see, that will have the closures working properly, and that will have class variables and all that, unless variables have come. So var means legacy code, and that is not modern code. So you will encounter such code bases in your life, and you should be ready for that. With this, I will end this video here, and in the next video, we will probably wrap up the discussion of functions. We will touch some aspects of functional programming, and we'll wrap the discussion on function. So thanks a lot for watching the video. I hope that you have found this video useful and informative. And I'll see you in the next one with the wrap-up video of functions. So after 4 days, I will have that video. And once again, thanks a lot for watching the video. Have a great day and enjoy.